For decades, if you asked an astronomer about Uranus, they'd probably describe a faint, featureless blue ball at the edge of our solar system. A cold, quiet, and, if we're being honest, kind of boring world. We knew it was strange, spinning on its side and hiding its secrets. Our only close-up look was a fleeting glimpse from Voyager 2 back in 1986. But now, the James Webb Space Telescope just peered into its upper atmosphere, and what it found there is challenging our fundamental understanding of how planets even work. Forget the pale blue dot. We now have proof that its completely bizarre, lopsided magnetic field creates auroras that behave like nothing else we've ever seen. This isn't just another pretty picture. This is the first time we've ever managed to see Uranus's upper atmosphere in 3 dimensions, and it solves mysteries that have been bugging scientists for over 30 years. So, let's break down what Webb saw thousands of kilometers above Uranus's clouds and why it's beyond what anyone believed was possible. To really get why this new discovery is so huge, you have to appreciate just how fantastically weird Uranus is. While other planets spin like tops, Uranus rolls like a barrel, knocked over by some ancient cataclysm.
Uranus looks bizarre. The rings, rather than looking like that when you look through a telescope, they're actually orbiting up and over the top of.
Its axis is tilted by a staggering 98 degrees. To put that in perspective, Earth's gentle 23-degree tilt gives us our seasons. Uranus has the most extreme seasons imaginable, with its poles getting 42 years of constant sunlight, then 42 years of total darkness. But the tilt is only half the story. The planet's magnetic field is even weirder. It's not centered in the middle of the planet, and it's tilted by an incredible 59 degrees from that already sideways rotational axis. Imagine if Earth's magnetic North Pole was down in Florida. As our planet spun, the magnetic field would tumble and wobble chaotically through space. That's just a regular day on Uranus. This bizarre shield has made understanding the planet a monumental challenge. For nearly 40 years, our only close-up data came from Voyager 2. It gave us tantalizing hints, but it was a snapshot that left us with more questions than answers. What did this crooked magnetic field actually do? Did Uranus even have auroras like Earth? Ground-based telescopes struggled to see through the thick, cold haze. The planet remained a pale blue question mark, waiting for a tool powerful enough to finally pierce the veil. That tool is the James Webb Space Telescope, and the world just saw the results. An international team of astronomers led by Paola Taranti of Northumbria University pointed Webb at this enduring mystery. For about 15 hours, nearly a full spin for the planet, on January 19, 2025, Webb stared at Uranus without blinking. The data they collected, published in Geophysical Research Letters on February 19, 2026, didn't just give us a new picture, it gave us an entirely new dimension. For the first time ever, scientists created a 3D map of Uranus's upper atmosphere. Think of it like a planetary CAT scan. Using Webb's incredible sensitivity, they traced the temperature and density of the ionosphere, the charged upper layer of the atmosphere, up to 5,000 kilometers above the planet's clouds. This is the region where the atmosphere meets space and where auroras are born. The map peeled back the layers one by one, revealing a complex structure that had only been theorized. It showed that atmospheric temperatures peak between 3,000 and 4,000 kilometers up, but the density of charged particles is highest much lower, at around 1,000 kilometers. This separation was a massive clue, telling scientists that whatever was heating the atmosphere and whatever was creating the charged particles were 2 different things happening in 2 different places. As lead author Paola Taranti said, "This is the first time we've been able to see Uranus's upper atmosphere in 3 dimensions. With Webb sensitivity, we can trace how energy moves upward through the planet's atmosphere and even see the influence of its lopsided magnetic field." But the true showstopper was the aurora. The 3D map delivered the most detailed picture of Uranus's auroras ever created, revealing 2 bright bands of glowing light. But unlike Earth's neat, polar light shows, The auroras on Uranus are warped and dynamic. Because the magnetic field is so dramatically tilted and offset, the auroras don't stay politely at the poles. Instead, they sweep and smear across the planet's mid-latitudes in complex, unpredictable ways. Even more fascinating, between these two bright auroral bands, Webb discovered something astonishing: a distinct dark region where the glow and the density of ions were massively depleted. This dark gap is direct visual proof of that strange magnetic field at work, creating a feature similar to dark regions also spotted on Jupiter. We are finally seeing in stunning detail how one of the strangest magnetospheres in the solar system sculpts its own unique light show. It's discoveries like this that are completely rewriting our understanding of the planets in our own backyard. If you're enjoying this journey into the cosmos and want to stay updated on the latest mind-blowing science from Webb and beyond, take a moment to subscribe. It helps us continue to bring these incredible stories to you. So, what does this all mean? Why does a 3D map of a distant ice giant matter? First, the data confirmed a puzzling trend that scientists have been tracking since the 1990s. The planet's upper atmosphere is cooling. Webb measured an average temperature of about 150 degrees Celsius, which is lower than previous measurements. This isn't a theory anymore, it's a measured fact. Understanding this is critical to figuring out the planet's energy balance, why it's so much colder than its neighbor Neptune. Second, this is a huge step toward understanding planets outside our own solar system. We now think that ice giants like Uranus and Neptune are the most common type of planet in our galaxy. Every detail we learn gives us a model, a Rosetta Stone, to compare against the thousands of ice giant exoplanets we are now discovering. As Paola Taranti noted, by revealing Uranus's vertical structure in such detail, Webb is helping us understand the energy balance of the ice giants. This is a crucial step towards characterizing giant planets beyond our solar system. This breakthrough isn't happening in a vacuum. In just the past couple of years, Webb has given us the clearest views of the planet's faint rings and even discovered a brand new tiny moon, bringing the planet's total count to 28. That moon, only about 10 kilometers across, was completely invisible to Voyager. Each discovery adds another piece to the puzzle, and this new 3D map is the crown jewel. It provides the context, linking the planet's interior, its bizarre magnetic field, and its atmosphere in one unified picture. For this reason, a dedicated mission to orbit Uranus has been ranked as the highest priority for the next decade by NASA's planetary science community. The work being done with Webb today is laying the essential groundwork, telling us what questions to ask and where to look when we finally arrive. From a featureless blue orb to a complex three-dimensional world of warped auroras and shifting temperatures, our view of Uranus has been forever transformed. We have peeled back the layers of its atmosphere and seen the intricate machinery driven by its tilted, lopsided heart. The James Webb Space Telescope has once again shown us that even within our own solar system, there are profound mysteries waiting to be solved. Uranus is no longer just a quiet, boring blue ball. It's one of the most dynamic and fascinating objects in our cosmic backyard. What do you think is the most fascinating part of this new discovery? Let me know in the comments below. And if you want to dive deeper into the mysteries of the outer solar system, check out our video on Neptune's powerful storms. Thanks for watching, and as always, keep looking up.